Hello everyone, myself Namita Amrutkar, Assistant Professor of Abeda Inamdar Senior College. In this session, we are going to cover Introduction to the Operating System. Agenda for today's session is what is my process, discuss different state of process control block, scheduling and fork command. Let's define process. A process is defined as an entity which represents the basic unit of work to be implemented in the system. To put in simple words, we write our computer program in a text file, and when we execute this program, it becomes a process which performs all the tasks mentioned in the program. When a program is loaded into the memory and it becomes a process, it can be divided into four sections: stack, heap, text and data. The above image shows the layout of the process. What is my stack then? The process of stack contains the temporary data such as method or function parameter, return address and local variable. Heap section contains dynamically allocated memory to a process during runtime. Text section, this includes the current activity represented by the value of a program counter and the content of the processor register. Data section, this section contains global and static variable. A process acts like a job in a batch process system and performable task of the time sharing system. Any kind of the program is divided into many possible small programs which are executed in the CPU one after another. The program which is currently executed in the CPU is known as the process. When a process runs, it goes through many states. Distinct operating systems have different stages and the names of these states are not standardized. In general, a process can be in one of the 5 states. First one, start. When a process is started, it creates first, it is in this state. Ready state. Here the process is waiting for a processor to be assigned to it. Ready process are waiting for the operating system to assign them a processor so that they can run. The process may enter this state after starting or while running, but the scheduler may interrupt it to assign the CPU to another process. Next state, running state. When the operating system scheduler assigns a processor to a process, the process state gets set to running and the processor executes the process instruction. Waiting state. If a process needs to wait for any resource such as for user input or a file, it becomes available to enter into waiting state, terminated state or exit state. This process is reallocated to the terminate state where it waits for removal from the main memory once it has completed its execution or been terminated by the operating system. Now we learn what is process scheduling. Process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process based on particular strategy. Process scheduling is the essential part of a multi-programming operating system. Such an operating system allows more than one process to be loaded into the executive memory at a time, and the loaded process share the CPU using time multiplexing. Categories of scheduling. There are two types of scheduling: non-primitive and primitive. In this case, in a non-primitive, process resource cannot be taken before the process has finished. When a running process finishes and transition to a waiting state, resources are switched. Primitive processing. In this case, the operating system assigns resource to a process for a predefined period. The process switches from running state to ready state or from waiting state to ready state during resource allocation. This switching happens because the CPU may give other process a priority and substitute currently active process for the higher priority process. In a simple word, We can say that non-primitive scheduling means when the interrupt is not occur when process is running. In primitive scheduling, there is a possibility that interrupt is occur when the process is in running state. Process control block. The operating system maintains the information about each process in a record or a data structure which is called process control block. Process control blocks act as an iCard of the process. The process control block registers all the information regarding to process and each user of the process has PCD. These all process reserve space in the memory for the operating system. At the time of creation of process control block are created and removed when the process are destroyed. There are various entries in process control block. First one, process ID. At the time of process creation, operating system allocate a number to the process which is called process ID. Process can be identified by its number, so it is called as a process ID. If the operating system allow for maximum of n process, the operating system reserve a memory area to define the process control block for an n process. The second one is a process state. This entry maintain different process states such as process is in active or block or ready or in other state. This information is kept in codified fashion in the process control block. That means it assigns some number to each state and it stores that number, so it is require less space. Next one, process priority. Some process can immediately complete their execution when they enter into the CPU. Such processes are known as a higher priority process, while some processes are wait for execution, which is known as a low priority process. Sometimes the higher priority process we want to execute first. Some priority are assigned by the operating system. Priority setup work is done by externally such as user or system or manager. Next one, pointer. Pointer to the process. This is used to store direct or indirect address or location of the process image reside in the memory. It also stores memory management information. It stores which area of main memory is used to store program and which is used to store data. It also stores starting address of the process. Next one, program counter. This is used to store address of instruction which is to become for execution in the CPU. Next one, input output operation. It stores how many input output devices are required for that particular process. Out of them, how many devices are allocated and how much devices are gets required for that process. And the next one, we have to store accounting information. This information store uses of resource such as CPU time, connect time, disk input output used by the process. It stores what time which resources are allocated to process and what time it is to be deallocated from that process. And the last compartment contains other information. This information contains path name, current directory, address, different scheduling queues. This information depends on the type of operating system. It also includes some process synchronization information. As we know, in the multi-programming system, more than one process waiting for the execution. All the process control blocks are maintained as a linked list. It is also contain ready queue header which store address of the first and last process control block. The operating system maintain the important process scheduling queue. First one, job queue. It is also called job pool. This queue is created in the main memory and used to store name of such a job which are currently in the second memory. The next queue is ready queue. This queue is is used to store process control blocks of all the process in the main memory. The queue keep set of all process reside in the main memory and waiting for to execute. A new process always put in this queue. Next one is a device queue, which is also called as a block process queue. This is again created in the main memory to store process ID of all the process who are currently in block state. This is also called as a device queue. Each device has its own device queue. Now we learn what is by scheduler. Scheduler are special software which handle process scheduling in various ways. Their main task is to select the job to be submitted into the system and to decide which process to run. The main objective of every scheduler is to save the time and increase the throughput and efficiency of the operating system and reduce waiting time. The long-term scheduling algorithm and short-term scheduling algorithm and mid-term scheduling algorithm are the three types of the scheduler. Now discuss one by one these schedulers. First,
now we explore long-term scheduler. It is also called a job scheduler. If the number of ready process in the ready queue becomes very high, the overhead of the operating system for maintaining long list, context switching and dispatching increases. Therefore, it is wise to let in only in limited number of CPU. The long-term scheduler manage this. It disallows process beyond a certain limit for a branch process first and in the end also the interactive code. The main objective of the long-term scheduler is to select once a job from job pool. It is also called job scheduler. It converts a job into process. It controls degree of multiprogramming. Degree of multiprogramming means total number of processes that simultaneously executed by the operating system. A job scheduler load more and more job into main memory. The degree of multiprogramming increase similarly when it controls loading activity. It provides good process mix of input-output bound and CPU bound to share term scheduler. Hence, it can increase throughput of the operating system. CPU bound process means such a process which is not required input-output operation. It contains only computing instruction, not input-output interface instruction. Input-output beyond process means process which are doing more input-output operation than CPU-bound instruction. Once a job is loaded into main memory, then work of job scheduler is passive and it becomes again active when it is terminated. Now we learn a short-term scheduler. Short-term scheduler is also called CPU scheduler. The short-term scheduler decides which of the ready process is to be scheduled or dispatched next. The main objective is to select one process from the ready queue and allocate CPU to the selected process. It is also called a process scheduler. In case of input-outbound jobs, ready queue is almost empty, so short-term scheduler has very less work to do. Short-term scheduler, also known as dispatcher, make the decision of which process to execute next. Short-term scheduler are faster than long-term scheduler. We learn a CPU scheduling algorithm on next session. Mid-term scheduler. At any time, the main memory of computer is limited and can hold only certain number of processes. If the availability of the main memory becomes great problem and a process gets blocked, it may be worthwhile to swap it out into the disk and put it at another queue for process state called as a swap out, and block which is different from a queue of only block process, hence requiring a separate process control block. Sometimes it is required to remove some number of jobs, that is pages, from memory temporarily and reduce the degree of multiprogramming. The degree of multiprogramming is number of processes which are available in the ready queue. Sometimes while executing a program, it is found that memory requirements of the program are changed. Therefore, the page of the job is to be removed from the memory temporarily. This is called as a swap out process. Another reason to remove the program from the main memory is that sometimes it is need to be load some required page into the memory. If there is not space, then it remove some passive pages from memory and load required pages into the main memory. This is called swap-in process. This algorithm is called as a page replacement algorithm. We learn page replacement algorithm on next session. This is used in demand paging algorithm also, and this is also used to overlay the type of linking. Now we learn operation on process. To create a new process, a Linux operating system provides one command which is called as a fork command. When operating system execute a process, then that process create a many small process as well as terminate so many small process dynamically. That all small process is called as a child process, and the process which create this small process is called as a parent process. Operating system gives two type of facility regarding process, that is create process and process termination. There are two main implementation exist in terms of execution of the process. The parent process execute with its children concurrently. When parents are terminated, its all children process are automatically get terminated. This is called cascading termination. Some operating system not allow this type of termination. Before termination of parent process, program has to terminate all its children process. Using fork command, child process can be created. If the parent process return a value greater than 0, that means you have to wait until the parent removes its execution. If parent process return a value 0, that means you have to execute process of the child process, and exit is used for system calls process is terminated.